Alright, welcome. In this video we're going to be working Algebra 2 Homework 1.2, and that's kind of getting started on linear functions, equations of lines, stuff like that. So first we're going to consider the line that passes through the points 3, 1, and negative 2, 0. And they're going to ask us to find the slope of the line. So we're going to use the formula for slope, right? Rise over run, y2 minus y1 over x2 minus x1, whatever you want to call it. So I'm going to say, and you might not need to copy the formula, but I'm just going to show you the formula so you can see where I'm getting the numbers from. Okay, so it'll be 0 minus 1 divided by negative 2 minus 3. So I've got negative 1 over negative 5, which is 1/5. Okay. And then we're going to write an equation for the line in slope-intercept form. Okay, well, slope-intercept form, that's y equals mx plus b. Okay, now we don't have a y-intercept, right? We don't know what that is yet. We'll be able to figure it out. We have an x-intercept. We have a value where y is 0, but that's not going to help us to get y equals mx plus b. We already have m though, so that's going to be where we start. We're going to start with point slope form because we've got a slope and 2 points to choose from. Doesn't matter which one we choose. So I'm going to start with point slope. We know that that's y minus the y coordinate of the point that we know that's on the line is equal to the slope times x minus the x coordinate of the point that we know is on the line. So I'm going to say, all right, I'm just going to choose 3, 1. It doesn't matter. You'll end up with the same answer if you choose negative 2, 0. And negative 2, 0 might be the way to go because you'd have less stuff going on here. Maybe I'll show you that. So I'm going to say y minus the point I know is on the line, okay, so that's the y coordinate is 1, is equal to the slope times x minus the x coordinate of the point I know is on the line, so that's 3. Okay. So now to get y equals mx plus b, I'm going to have to distribute this 1/5 and then eventually add the 1 over there. So I'm going to say y minus 1 is equal to 1/5 of x minus 1/5 of 3. So I'm just going to call that 3/5. And then I'm going to add 1 to both sides, right, to solve for y. And so 1, that's 5/5. So if I have 5/5 minus 3/5, that will be a total of 2/5. Okay. Now, I'm just going to show you, in case you didn't believe me. If you did believe me, or you know it's right, skip on to the next one. I'm going to do this one again a little faster, but using the point negative 2, 0. So y minus 0, if I'm using that point, is equal to 1/5 of x minus negative 2. That would be x plus 2. And then I'm going to distribute, right? So I'll have y minus 0 is equal to 1/5 of x plus 2/5. Wait a second, y minus 0, that's just y. So y equals 1/5 x plus 2 over 5, which is the same thing I'd gotten using the other point, right? It does not matter. You're going to end up in the same place. Right, now we're going to consider a line where they give us its standard form equation. So that's 3x minus 2y equals negative 18. So we're going to find the slope of the line, and if you just have a formula for that ready to go, then you can just go ahead and use that formula. What I'm going to do is I'm going to work this around to y equals mx plus b, because I know eventually I'm going to have to find the y-intercept, and that'll show me the y-intercept. So, all right. So I'm going to maybe subtract 3x from both sides. So I'll have negative 2y equals negative 3x minus 18. And then I'm going to divide both sides by negative 2. Or multiply them by negative half. And then when I distribute, I'm going to have y equals positive 3/2 x plus 9. Okay. And if we're just looking for the slope of the line, that's just going to be this 3/2 number, right? The number that's attached to x. Now, I know that the y-intercept needs to be 9, but I'm going to show you why this is true. Remember that if we've got standard form, that's what that's good for is finding x and y intercepts, right? So I'm going to say the x-intercept, that's where y equals 0. Okay. And y equals 0, if I plug in y equals 0 into this equation, I'm going to get 3x minus 0 equals negative 18. So that's just 3x equals negative 18. And then I'm going to divide both sides by 3, and I'm going to get x equals negative 6. So I might say that my x-intercept is the point where x is negative 6 and y is 0. For the y-intercept, that's going to be where x equals 0. I'm just going to plug in x into this equation right here. So I got 3 times 0, that's 0, minus 2y equals negative 18. Okay, well, that's just negative 2y equals negative 18. I'm going to divide both sides of this equation by negative 2, and I'll get y equals positive 9. Okay? So my y-intercept is going to be the point where x equals 0 and y equals 9. And that's what I was seeing over here, right? The y-intercept, I knew it was going to be 9 because I worked this equation around to slope-intercept, and I saw that the intercept is going to be 9. So that's good that we were confirmed. Okay, if 1 and a is on the line, what is the value of a? Okay, so this is just a point, right, where the y-coordinate we don't really know yet. But what we're going to do is we're going to plug in x equals 1 and y equals a. Okay, so that's 3 times 1. Minus 2 times a equals negative 18. And then now we're back to what we did last time where we're going to solve for a, right? It's one variable word. We know how to do this. Okay, so this is 3 minus 2a equals negative 18. So maybe I'll subtract 3 from both sides. So that would be negative 2a equals negative 18 minus 3 more is going to be negative 21. And then I'm going to divide both sides by negative 2. I'll have a equals negative 21 over negative 2, which is just going to be 21 over 2. You could call it 11.5. I would ask that you call it 11.5 if you're going to call it 11.5. We don't like mixed numbers. So we're going to say, I'm going to just call that 21 divided by 2, because that's a perfectly fine version of that number. Okay, now we're going to give a sketch of the graph of the line. Okay, for my money, the best way to give a sketch is if we've got the x-intercept and the y-intercept, right? So I'm going to just real quickly come in and put in some axes. And now I'm going to label my axes because that's always good practice. And since I knew that the x-intercept was over here where x was negative 6 and the y-intercept is up here where y is positive, I'm going to kind of favor this quadrant up here. Okay, I'm going to give myself more area where x is negative and y is positive. It's going to make my graph look better, but you can do whatever you want. You can make it where they're even, and it's just a sketch, right? It doesn't have to be the best sketch ever. So I'm going to label x equals negative 6. I'm just going to decide wherever that is. I'm going to say it's right here. And then where y equals 9, make your graph look as nice as possible. 9 should be a little more than 6, right? So I'm just going to go a little farther than I went to the left up. I don't know if that's, to scale, but I don't care. And then I'm going to go over here. I'm going to get my ruler. And you don't have to get a ruler, but if you want your sketch to look nice, you should use a straight edge. And then we're going to come through, and we're going to connect the dots, right? And that's going to give us a line. And that's going to be a really nice sketch of that graph. And see, no grid necessary. You can still make a good graph without a grid. So, all right, now we're going to look at a line and write an equation for it. Okay. So what we're going to need is, especially if we can see the y-intercept, we're going to want y equals mx plus b. We want slope-intercept. So then our job is kind of to see, what's the slope, and we're going to need to get 2 points and compute the slope here. So over here, I can see that the intercept is 7. Right there. I'm not sure if you can see that. Yeah, you can, definitely. Okay, so I'm going for y equals mx plus b. Okay. B is looking like 7. So I just got to figure out what m is. And so I'm going to go over here, and okay, this is between 3 and 4, and because 3.5 divides 7 evenly, I'm just going to assume that's the point x equals negative 3.5 and y equals 0. So my 2 points are 0, 7, and the point negative 3.5, 0. And so I'm just going to compute the slope between these 2 points, right? I'm going to do y2 minus y1, 0 minus 7. Keep it still on the screen. 0 minus 7 divided by negative 3.5 minus 0. Okay, so that's negative 7 divided by negative 3.5. That's going to be 2. And, you know, if you need a calculator to convince yourself of that, there's no shame in that. This is the homework. You're always welcome to use a calculator on the homework. I can't keep you from using a calculator on the homework, right? So just have at it. That's going to be a slope of 2. And then that looks pretty reasonable. We can see it's a positive slope because it's, as we move to the right, the line is going upward. So that's a good sign. And, you know, it looks kind of steep, so 2 seems reasonable. Okay. And so the equation for this line is y equals 2x plus 7. And then for this one, I think, okay, it's really hard to tell here. Okay, if it's hard for me to tell looking at the actual sheet of paper, I'm sure it's really hard on screen. So what we're going to do is we're going to zoom way in and, okay, I'm going to find 2 like grid points, or yeah, grid points that this line is going through. And I see 0, 2, right? So I know that the intercept is equal to 2. But then this next one, it's kind of hard for me to see. I can see it's probably 5. I can't imagine that they would make it 5.5, right? So I'm going to say that this intercept is happening at x equals 5. It looks like, you know, it's a little to the right, but 5.5 divided by 2, you know, like we're not going to want to do that slope. So I'm just going to say this is at the point 5, 0. Not sure where I got this graph from. Let's see how zoomed in were we before. Sure. This will be good. Okay, so now I've got the point where x is, oh, that's one right there. Okay, yeah, that looks like it's supposed to go through that grid spot too. So I'm feeling pretty good about this being a 5. So x is 0, y is 2. X is 5, y is 0. And then I'm going to compute the slope. So the slope is going to be y2 minus y1 divided by x2 minus x1. And that, you know, that's looking like negative 2/5. And then you know, I know the equation I'm going for is going to be y equals mx plus b. So I've got my b, I've got my m. I'm just going to plug in on those numbers. So y equals negative 2/5 x plus 2. Well, this next one's kind of nice. F of x equals kx minus 2, where k is some constant that we don't know. Okay? But they're going to tell us that the graph of f has an x-intercept of 4. Okay. We know that an x-intercept is a place where y is equal to 0. So that means that the point 4, 0 is on this line. So we just got to figure out what the value of k is. So we're going to plug in when x is 4, y is 0. We know f of x, that's just code for y. So I'm going to plug in 0 for f. K times 4 minus 2. Okay, another way we could have looked at this was that f of 4 is equal to 0. And so we would have plugged in 4 for x and 0 for f. It's same thing, just dressed in different clothes. Right? So I'm going to say 0 equals 4 times k minus 2. And then we're back to what we did last time. We can solve this equation by adding 2 to both sides and then dividing by 4. Okay, so I'm going to add 2 to both sides. And I'm going to divide by 4, and I'm going to say k is 2 divided by 4, which is the same as 1/2. And then sketch the graph of f. Not sure I'm supposed to do that, but let's see. It's got a y-intercept of negative 2, and an x-intercept of 4. So I'm going to I'm just going to say that's -2 for y. This is 4 for x. I'm going to just get a, good morning. I'm going to get a straight edge, come through here. Sketch the line. Okay, beautiful, wonderful. Not quite. Forgot to label my axes. I'm prone to forgetting to label my axes, but I'm trying to be better about that this year. So, g of x equals 3x minus a, where a is a constant and g passes through the point 1 and 1, so that means that g of 1 equals 1, or when x equals 1, y equals 1, and y is g of x. So, I'm going to say 1 equals 3 times 1 minus a. And then we're going to solve for a just like we did over here with it. So, I'm going to say this gives me 1 equals 3 minus a. And maybe I'll subtract 3 from both sides. So 1 minus 3 is -2. If I want to get rid of this negative, I'm going to multiply both sides by -1, divide both sides by -1, depending on how you're looking at it, same thing. And I'm going to say that a equals 2. That one was nice. Okay, let h be the function 1/2 of x minus 2, and then add 5. What's the intercept of y-intercept of the graph of h? Okay, y-intercept, that's where x equals 0. Okay, so we need to find the value of h of 0, or the value of h where x equals 0. So I'm going to just go over here, and I'm going to say h of 0 equals 1/2 of 0 minus 2. We've just plugged in 0 for x, plus 5. So half of -2 is -1, plus 5, that's going to be 4. Okay. So the y-intercept is going to be the point where x is 0 and y is 4. And then we're going to sketch the graph of h. Okay. So I know that it goes through the point 2 and 5. If I was to work around it, would be in point slope form. But I think since, let me think about this. I already got the y-intercept. I'm realizing that I could have also just, distributed over here and tried to get it y equals mx plus b, and you could have seen the intercept as b. Either way, I'm thinking about the graph. Well, I'm just going to compute the x-intercept. I'm sure there's a better, faster way to figure out, another point that I can use, but I've been kind of liking to sketch my graphs by just putting in the x and the y-intercept and then connecting the dots, so I think I'm just going to keep with that. So the x-intercept is going to be where y equals 0, so I plug in 0 for h of x, and I'll have 0 equals half of x minus 2 plus 5. And this will be, this will be a good one for us to work on solving, so we're going to subtract 5 from both sides. And then, okay, this is in parentheses, so I'm going to have to access it last. So I'm going to get rid of this half by multiplying both sides by 2. So I have -10 equals x minus 2. And then to get at that x, I'm going to have to add 2 to both sides. So -10 plus 2 is going to be -8. I'll say x equals -8. So I know the point -8 and 0 is on the graph of h. So I've got a negative x-intercept and a positive y-intercept. This one, -8 is going to be this. I'll just say that's going to be +4. Bring in the straight edge. I've got myself a sketch. Okay. The wise algebra student, I think, actually knows that, okay, I'm going to have a general idea of where I want the x and y intercepts to be, draws the line first, and then labels the intercepts after, right? That'll make your sketch look as good as possible. Yeah. Now, f of x equals bx minus 6, all divided by 2, where b is a constant. Okay? This is going to be another one of these plug-in problems, right? We're just going to plug in x equals -2, f equals 5. So 5 equals b times -2 minus 6 more divided by 2. So to get at b, I'm going to probably have to deal with this fraction first, because it's like these are in parentheses when it's the whole numerator. So we're going to multiply both sides by 2, and then I'm going to have 10 equals negative 2b minus 6. I'm going to add 6 to both sides. And then I'll be able to access b by dividing both sides by negative 2. So I'm going to say, okay, in this situation, b equals negative 8. Okay, then it's going to be 2/7 of x minus 4. Okay, find the value of g of 0. That's just what we get when we plug in x equals 0. So I'm going to say g of 0 equals 2/7 of 0 minus 4, and that's going to be equal to just negative 4. Because anything multiplied by 0 is going to be 0. Okay, find the solutions to the equation g of x equals 0. There's only going to be one solution right now because we're just dealing with first degree scenarios. So if g is the thing that's equaling 0, I'm going to plug in 0 right there in that equation. So I'm going to have 0 equals 2/7 of x minus 4. Okay. And we're solving for x. So I'm going to add 4 to both sides. Okay. And now if you wanted to multiply by 7/2, that would be fine. I think I could probably see what's going to be 7/2 multiplied by 4. But for me, I'm going to multiply both sides by 7 first. I'm going to do it in 2 steps. Right? I got plenty of time, plenty of space. No big deal. Right? So 4 times 7 is going to be 28. And that's going to be equal to 2x. And then I'm going to divide both sides by 2, and I'm going to get x equals 14. But if you wanted to go over here and take x equals 7/2 of 4, and you can realize that that's 14, you'd be my guess. Okay, you do that. So what's the x-intercept on the graph of g? Well, that'll be the place where y is equal to 0. That's the same as saying g of x equals 0. And I already solved that equation, right? Okay, so I'm going to say it's x equals 14. So it's the point where x equals 14 and y equals 0. And then if they ask what's the y-intercept on the graph of g, well, we know the y-intercept is the place where x equals 0. So that would be where we're plugging in 0 for x. So that's the g of 0 thing. And we already did that. We found that g of 0 was negative 4. So I'm going to say that the intercept is the place where x is 0 and y is negative 4. Right? There's no sense in doing that work twice. Okay. And then we're going to write a standard form equation for the line represented by the graph of g. Okay, well, let's write down the standard form again, just in case you forgot. That's ax plus by equals c, where preferably a and b are integers. Right? But that's why we said a standard form equation. There's going to be a lot of standard form equations, right? You could multiply both sides of the equation by 2 and have the same line, but the equation would look very different. So what I'm going to do, I'm going to try to take this, and I'm going to start with y equals 2/7 x minus 4. And, well, suppose I'm going to subtract the 2/7 x over here. And it looks like I did not leave enough space here for us to solve this problem, but that's all right. Just a little scrap of paper. And what am I doing here? And we need to get rid of this divided by 7, right? I don't like the way that looks. I want these to be whole numbers. So I'm going to multiply both sides of this equation by 7. But I have to remember that when I do that, I have to multiply everything by 7, not just this thing and that thing, but also the y. So I'm going to have negative 2x plus 7y. It's not a y. Made it almost all the way through without making an error, but that's just how it goes, You make some errors. So negative 2x plus 7y equals 7 times negative 4, which is going to be negative 28. And that's a standard form equation. Check. But maybe you want a to be positive. Maybe you think a always has to be positive in standard form, which I don't know. Maybe it does, maybe it doesn't. If that was the case, then what I would do is I would multiply both sides of this equation by negative 1, and then I would have positive 2x, negative 7y, and positive 28. As another standard form. But like I was saying earlier, I'm not sure why a person would want to do this, but if you wanted to, you could double both sides of the equation, and you could say 4x minus 14y equals 56. And these are all three different equations for this same line that's represented by the graph of g. Okay? So that's all I've got for you for this video. Thanks for watching.